Hello, classmates. While I am going to upload videos of me actually doing lecture and teaching my students, I wanted to give you a chance to see how their class is set up. We live in Schoology for our corporation. This is actually my second year teaching from Schoology. I was one of the pilot teachers who started this out last year. So this is my chemistry for the semester. You can see that we have done solutions, acids and bases, nuclear chemistry, and thermodynamics. Here in the middle of between nuclear chemistry and thermodynamics are all of the e-learning assignments that I have given. We are supposed to be doing a folder a day for each student. So as you can see here, we had e-learning on the 14th, the 15th, and the 16th. No, I'm sorry, the 20th, the 21st, and the 22nd. That was e-learning day number 14, 15, and 16. Now that this week is complete, I will put those all into one folder so that it looks more like this, e-learning week 13 through 17. When you open up one of my folders for e-learning day, it takes you to a page. The reason we have it set up like this is because I have it set up for student progress. So I can see when the students have looked at that. That is how my corporation is taking attendance these days. Also, in addition to that, that gives the kids a green check so that they know when they have done that. So you can see that e-learning day number 16th, which was April 23rd. Today's notes are on calorimetry. Open the guided notes in the thermochemistry folder and follow along as you watch the video. We will do half the notes today and half the notes next Tuesday. Office hours today on Zoom from 11 to 12. I would love to see you. I've been having office hours each Thursday from 11 to 12 for chemistry. So here's the thermodynamics folder, and this is what a typical folder looks like when we're doing e-learning or not e-learning. At the top, I have my lesson plans in here so the kids can see exactly what we're doing each day so there's no questions. And then typically we start with the PowerPoint and guided notes. So the PowerPoint is posted here. The guided notes are posted there. And then after I lecture, when I lecture at school, I do go ahead and video so that it is there for kids who are absent or who want to go back and rewatch again. Obviously, I've been doing instruction virtually, so that is where those these videos are from, is from my home, not at school. But earlier in the year, if you would have opened it, it still would have looked like this because I would be putting those videos there for each of them to see. So we've got the lecture, the guided notes, and then the videos that go along with them. In this unit, the students have been doing virtual stations. They did a thermochemistry simulation. They did a practice worksheet, all that went with this information from this PowerPoint and these guided notes. So with that PowerPoint, we did virtual station, thermochemistry simulation, and a practice worksheet. And then they took a quiz online based on that. Then we started the process over again with calorimetry. Here's the PowerPoint, here's the guided notes, here's the lectures for both days. They did an enthalpy practice. This is a worksheet. Then they're going to do an online practice. When they finish doing their online practice, they're supposed to screenshot their score, and they've done this multiple times so they know exactly what they're doing. Then they go here and they post their screenshot so that I can grade it and give them credit for it. And here is their thermochemistry test that we're going to do at the end of this. So a couple things that I wanted to take you through on my student side of work is the first is the virtual stations. So the way that Schoology is set up is when the kids open this, it says virtual stations and it'll say assignment. And then where I have in progress and submissions, they will have something that says my document. And when they click on that, it makes them a copy of the document that they work through. I just thought maybe we could go through a submission of someone who did a good job. How about Parker Dillon? All right, so when they open up this, and then when they're finished, they turn it into me. So you can see that there's a thermochemistry virtual stations. That's the beginning. Their second slide said, hey, today we're doing virtual station rotations, and it told them the days that they're going to be doing it and when it's due. Stations are standard in my class, so this isn't anything new. They are used to working through it at school. I really like to do it so that they move from table to table. I feel that at school, when we are actually there in a group, the act of getting up and moving works really well. In my classroom, I like them to be doing something. So when I do stations, I typically set it up at lab stations, and we will time. I'll be like, all right, you guys got 7 minutes per station. I'll give them the time, and then I'll say rotate, and the whole class will rotate. Typically the first time I do that, it's maybe like a little bit of confusion because they're not sure of like the movement pattern or whatever, even though I explain it before we go through it. But after a time or two, they've got it down and they know exactly how they're supposed to move and rotate through those stations. Now, most of the time when we're at school, it's hand-on application. Obviously, at home, we can't have those. So I did try to add some things that would maybe be fun for them. Station 1 was just definitions. Station 2 was using those definitions and applying them to real life situations. Then station 3 was vocab, drag and drop. So they were supposed to pick up the boxes and drag them to the arrows there. That was station 2. Ooh. His is messed up. That was station 3. That's all right. So station 3 was they were supposed to write multiple choice questions for me and highlight the correct answer. So I gave them this box like this. So they were supposed to ask the question here, and then they gave me 4 options with the answers. I actually used these questions or some of them on their quiz, and I gave the kids extra credit if I used their question. Station 4 was solving problems. You can see here that I went through and made comments to the students, like here. He has his equation set up incorrectly. So I highlighted that and I made a comment to him. I told him what equation he was supposed to be using for those so that he knew that he had a mistake and he would get feedback so that he could fix it in the future. All right, and then station number 5 was an article. They clicked on that link right there and it took them to an article. Then they had to answer questions based on that, so it was a reading. And then station number 6 was a Google form. They clicked on that Google form and they had to work through 3 questions. At the end of the Google form, it gave them a code word and they were supposed to enter the code word here. I also checked to make sure that they accessed the Google form and actually went through it. Of course, you can see anybody who accesses a Google form, so that's kind of cool too. We can go to that Google form and look at that real fast. It just looked something like this. This is a super easy way to do stations or to add some virtual things to your. So station number 6 form, they had to answer the question. They had to get the answer right. And if they didn't get the answer right, like I'm going to put in the wrong answer. I'm going to push this, and it said, oh, it gave them the answer. Oh my goodness, I have it set up wrong. Okay, well, I'll put in the correct answer, and then it takes them to the next question. So they're supposed to go through the questions, and then at the end it gives them the code word. So that was the virtual stations part of this. Now, like I said, obviously we are living in a virtual world right now. So things are a little different than what I would be doing at school. At school, we would be doing some different labs, and we couldn't do that. So I had the students do a thermochemistry simulation. When they opened this, they would see my document right here, and they would open that up. Now, when they open that up, it takes them to their Google Doc right here. It will make them their own. The link for the simulation was here. So it says open the simulation and watch the beginning video and then go to the second part of the simulation. It gave them the directions on what they were supposed to be doing as they worked through the simulation. These simulations with the K-12 are awesome. The CK-12, they're awesome. Because I have already been on here, I've already watched it. So there's just a little video here at the beginning talking about sports and relating it to real life. And then they are supposed to be looking at cold and hot packs. Now, this is the first time that they have seen this energy diagram, so this is all new for them. So they've clicked sodium chloride and they hit the play button. It shows the pack breaking, and you can see what has happened. It shows that energy is absorbed, and you could watch the temperature. So I'm going to pause it. I'm going to pick a different one. I want to go back to the sodium chloride. So you see that the temperature is 21 degrees Celsius, and as the reaction starts to take place, the particles begin to move apart and the temperature drops. So they can do that. They were supposed to do that for each of the four substances. And as they worked through that, they were supposed to fill out this diagram on the sheet, answer a couple questions, and then at the bottom, the students are supposed to be doing claim, evidence, reasoning. So this is something that they worked on all year. I introduced it the very first week of school, and in my class, they highlight those things. So they start by making a claim. So the question is, chemicals used in cold packs do not contain ice, so why do they feel cold on your skin? So the first thing they would do is make a claim. Cold packs feel cold on your skin because of the chemical reaction happening inside of it. Then they would give the evidence from the simulation that you can see as the reaction happens that the temperature goes down, and then they would give the reasoning. Why does this happen? And they should talk something about endothermic or exothermic reactions and how the heat transfer from the system to the surrounding causes things to feel cold and hot. All right, so after they finished that, after the students finished the simulation, the next day they were supposed to go to Flipgrid. And Flipgrid is something that we have been using in class, and they know exactly how to use it. Obviously, you have to sign in with your Google. So it'll say chemistry period 1. If you look at my thing, each class has their own Flipgrid. So period 1, period 4, period 7, they had to click on the correct one. And you see that there is a little video from me. I'll go ahead and play that.
Hi guys, hope you're doing well. I just wanted to tell you that this week's video, you need to give me a real life example of heat transfer. Tell me 2 things you've learned about thermochemistry so far, including like examples with endothermic and exothermic reactions, and then ask a question. This question needs to be related to thermochemistry, and the second part of your grade for these videos this week is going to be your interaction with your classmates. So you need to watch their videos and then go back and record a video of yourself answering the questions that they ask. So good luck, enjoy, and I'm looking forward to seeing what you guys have to say. Bye.
Okay, so then you can see that my students came down here. You can see them here, and they recorded videos of themselves based on those requirements. Give a real life example of heat transfer. Tell me 2 things you've learned in this unit. Tell me 1 thing you still don't understand, and then interacting with their classmates. So let's just watch one of them very quickly. All right, good job, Zoe. Now, here are a couple answers.
The answer to your question is that the type of the temperature fluctuates with how far apart the molecules are, like if they're closer together or if they're farther apart.
That wasn't a very good answer, but that's okay.
Hey, so to answer your question, the reason why they get hotter or colder is because when the chemicals mix together, they either move faster or slower.
There you go, Ty.
To create heat or to make it more cold.
Great job. So that is an example of the interactions that were happening here on the Flipgrid, and each of the classes had their own. I did go back through and grade all those, which was a little bit, was a lot. So that is an idea of what we have been doing here in chemistry. I'm going to go back here and look and see what else I have in my thermodynamics folder. All right, so we did virtual stations, we did a simulation, we did the Flipgrid. This is just a practice worksheet where the students worked through problems and then they applied that knowledge to the quiz. So I hope that gives you a little bit of an idea of what's been going on in my class and hopefully shows you some different ways of learning.